Okay, a penny whistle is 31.9 centimeters long. It has a fundamental frequency of 503 hertz. It's a both ends open pipe. So the other opposite end of the penny whistle is open, and then that little slot that you see at the top of a penny whistle, that also counts as an open end. Flutes are the same way. So the place where the mouthpiece is open, right? Okay. So draw the first harmonics. Remember, the first one is this guy. All right, the next one is this guy. So these are a quarter of the way in, by the way, if you're being careful. And then the next one is it's got a node in the middle. If you would watch the video flips, you would note that. It's so quiet as I make this video. I don't even know if you're laughing. Okay. Okay, let's see. It's opened at both ends. 503. Oh. Ooh, that's cool. Okay, 503. Okay. So notice that we're given not the wave speed, but what the fundamental frequency is, right? So calculate the wavelength and frequency for each, okay? How to do that? Well, let's do it. Okay, so what we do for this guy is we say, okay, look, there's 2/4 wavelengths there. So 2/4 wavelengths is 0.319 meters. So therefore, the wavelength is times 2. It's 2 of those, right? So 0 wavelength is 0.638 meters. All right. Got it. Okay. And then what is our frequency? Well, they tell us the fundamental is 503. Okay. Well, remember that this guy goes 1F1 or 1F0, right? This guy will go 2F0. This guy will go 3F0. Okay. So this guy is going to be twice that. So that's going to be 1,006, right? If this guy's 503 hertz, this guy is going to be 1,006 hertz. And this guy is going to be 1,509 hertz. Because this pattern goes 1, 2, 3. Remember, if it's a pan pipe, if one end's closed, it goes 1, 3, 5, 7. It skips all the even ones. Okay, but that's the way this one works. Okay, so we've got the wavelength and frequency. The wavelength is that. The frequency was given to us, by the way. All right. Okay, so let's do the next one here. So if we look at this, we've got how many quarter wavelengths? 1, 2, 3, 4 quarter wavelengths. So 4 quarter wavelengths is equal to 0.319 meters. So the wavelength is 0.319 meters. Okay, and then the frequency is just 2 times 503. Which is 1,006 hertz. All right, so let's look at this guy. How many quarter wavelengths do you see? It's like kissing fish. 1, 2, 3, 4, 5, 6 quarters. So 6 quarter wavelengths is 0.319. So 0.319 times 4 divided by 6. Is what I do. Okay, so I'm getting that the wavelength is 0.2126 bar meters. Okay, so let's see. Did we get that right? Yeah. We've gotten our wavelengths right. Yeah. And then our frequency here is going to be 3 times the fundamental. This is the fundamental, right? So 3 times 503 is going to be 1,509 hertz. All right. Okay, so let's see. What is the frequency of sound for this pipe? Well, for any of these, you can just simply go V is F lambda. Now, kids want to know which F lambda should we use. you should be able to use any of these, right? I'm going to use the fundamental because that's what I was given that, and I figured out this, right? You could use this one. I mean, let's just do this, okay? So I'm going to go, the frequency is 503 for the fundamental here. Well, that's like a phone number. Okay, 0.638 is our wavelength there. It's a 6. Okay, so 503,452, no, just kidding. Okay, times 0.638 is 320.914. Now, this should be the same thing. Let's just try it. Let's go 0.319 times 1006. I get the same answer, right? You only have to calculate it once. I'm just saying, but if you go this times this, you should get the same answer, or you mess something up. Okay, let's take this other one. Exactly, I'm going to take the exact number on my calculator and multiply by 1509. And I get exactly the same number. Only there's like a little bit of round off error because this number was rounded by the calculator. Okay, so the velocity is just this. Okay. Okay. If I lift a finger off the whistle 4.7 centimeters from the end, the pipe is shortened by that much. What is the new fundamental frequency? Okay, party line, this is what we're supposed to do. Let's find the new length. The new length is 31.9 minus 4.7. 31.9 minus 4.7 is 27.2 centimeters, right? Or 0.272 meters, okay? So now we just set it up, right? We want to know the new fundamental frequency. This guy's the fundamental, okay? So 2 quarter wavelengths is equal to 0.272, okay? So the wavelength is equal to 0.544. Okay, now what is our frequency? Our frequency is going to be velocity over wavelength. So this is our velocity, 320.914 divided by 0.544. Okay, so that same number divided by 0.544, divided by 0.544 is 589.9 hertz. Okay, let's see, did we get that right? Yeah, 590 hertz. That's what it says. I rounded it to 3 sig figs, okay? Now, I bet there's a slicker way to do this, okay? Remember that I had to erase to do this. I'll show you a slicker way to do this, right? Okay. So to do this last thing, right? The new length was 31.9 minus 4.7, or 27.2 centimeters, right? And then the new frequency is going to be higher, and it'll just be a proportion of this and this, right? So 31.9 over 27.2 times 503. Let's try it. 31.9 divided by 27.2 times 503, and we get 589.9. And the reason that works is that, of course, this is all just direct proportions, right? Yeah. And why did I put the big number on top of the small number? Because I know it's going to get to be a higher pitch, so I just use those numbers and turn them so that, yeah, if you don't like that, do the way you're supposed to. All right.